Hello guys, we are at the University of California, San Diego. They have some interesting showcase being put on here. We'll talk to Chris on what actually it is and what the research work is all about. Hey Chris, can you introduce yourself and where are you from?
Hi, I am Chris McFarland. I'm a computer programmer who works at the University of California, San Diego. I'm a staff programmer there, and what you're looking at behind you is one of our research systems. We call it a wavelet. It consists of 4 HD 3D TVs, and on the screen what you're looking at is the remains of the oldest known human remains in the Americas, they were found in a site, I believe 140 feet underwater in Mexico.
So what is the research project all about? What was the need for doing this using this technology in particular?
So we work on a number of different things, archaeology, computer science, structural engineering, primarily related to cultural heritage. I'm a programmer for my specialty, and so some of the things that I've worked with are interaction systems, so that you can fly around these displays easily. What you're looking at here is a point cloud that is constructed out of photographs. So essentially, you just take a whole bunch of pictures and you can rebuild the 3D structure of what you're looking at. Okay. So since this was so far underwater, it's difficult to remove the pieces without damaging it. This gives the archaeologists a way to study the site without having to go there 140 feet underwater themselves, without having to remove the pieces from the site, possibly damaging them on the way up.
So how was the photographs taken actually on site?
It was taken by a diver with a camera.
Can you talk more about the project work?
Sure. This particular scene is from a cave called Hoyo Negro. It was actually in the cover story on National Geographic recently. A diver named Alberto Nava, who was here yesterday, is one of the guys that discovered the cave. And so in this area, what they did was it's a very large cave, it's pitch black, but they lit up this area, and he took thousands of photographs that overlap very much. And those photographs essentially are then pushed into some software that does pixel matching, and it finds common points amongst multiple photographs. And then from that, you can get X, Y, Z points. So in this scene, and if you look at this in 3D, you can see that this is a centimeter, this little black line, and the number of points that's there, I mean, we're talking about, incredibly like sub-millimeter resolution. So this whole process of collecting data is called structure from motion, and these are the bones of this young girl named Naya. So I don't know, it might be redundant with some of what Chris said, but it's an incredible way. I mean, this is only a 2 by 2 meter area, which is pretty wild when you think about it, because you have almost 1 billion data points.
Exactly, the level of detail of each structure of the bone you have.
And you're never there's many researchers, multidisciplinary folks interested in this area. Some of them are interested in the paleontology, some are interested in the anthropology and the archaeology. This gives us the opportunity to be able to do precise measurements from Switzerland or whatever, right? So that someone can come in and virtually not just look at this and say, oh, isn't this cool, but they actually have that ability to do real science from a remote place.
Okay, sure, thank you. What is this device all about, and how do you use this to capture the data?
So this is a prototype of what we call a cave cam. This is for the next generation. Essentially, it consists of a pair of cameras mounted on a tripod. You can spin it around, it tilts up and down. It takes 72 pictures per eye, so 144 total pictures, which we then stitch together to make high-resolution stereo panoramas. So what you're looking at here is a site in Florence, Italy. This is the Duomo, and essentially it was part of a research expedition several years ago to study the state of health of the baptistry and several other sites in Italy. So while our archaeologists and structural engineering team went there, they captured this high-resolution imagery. So this gives you essentially a digital record that allows you to determine essentially the state of health of historical buildings and archaeological sites. Okay. So you can go to a site, take some pictures, measurements with laser scanners and other techniques, come back later, see has your site deteriorated, has it improved from doing enhancements and reconstruction work.
Can you show the Egypt example also? Sure. So you developed the software also for this?
We developed this rendering software as one of our research projects.
Okay.
I wasn't involved with writing this software specifically, although I did help with the game controller.
Okay.
So to fly around this and spin the display,
Okay.
it works with a PS3 controller.
Okay, sure. Can you talk about this project in Egypt that you're showing here?
So these images were taken by Tom DeFonte. He is one of the researchers who works with us. When he traveled to Saudi Arabia for a project a few years ago, he got an opportunity to go over to Egypt. So I believe around the time of the first Egyptian revolution, he was able to go over there and take these images. One of the things which is really nice about doing this in 3D, you can't see it in the video here obviously, but if you do get a chance to ever visit this and see it, one of the things that you don't get an impression of from pictures and from books is really the depth of the carvings that you see like on these pillars here.
And what is this project all about?
So this is a research project that focused on good uses for drone technology. So we have researchers who are building with 3D printing and other techniques their own hexacopter drones. Last year there was a big earthquake in Napa Valley, so some members of that team went up to this winery in Napa Valley with their drone. They attached a camera to the drone. It flew around for about 20 or 30 minutes and took several hundred pictures. And from those pictures, this is a 3D reconstruction. So you can see here the doors in the middle are where they should be, and the frame is obviously distorted around it. The whole building here is being held up by construction equipment. Otherwise, it would have fallen over. So the team who took these pictures uploaded them with their cell phone back to our lab, did a rough reconstruction overnight, downloaded the low-res version, not to this quality, but a useful version of it to make sure that they were able to acquire the data. Hopefully with the improvements in the algorithms and with hardware over the next few years, that may become fast enough to use for rapid response, disaster planning, and other situations like that.
Okay, sure. Thank you, Chris. Thanks for the inputs.